on this computer. Okay, you can see this is the problem. Right? This is problem number 1. Correct, right? And the question is,
yes, sir.
You just need to replace all forces and moment there with one force. With one force in which happening at axis y. It's y-axis like that. So basically, you can do like what you did before, right? I explained to you before already, right? That you can move all these forces. Okay, you can move force which is happening at point D to point C. Okay, and at the same time, while moving it, you will create a couple moment as well. Okay, and you can move as well this force from point B. Okay, you can move the force from point B to point C like that, or okay, you can move from point B to point C like that, the same point as before. While doing that, you will create a couple as well. Okay, then what you have there will be 2 forces which is happening at point C, 20 newtons and 10 newtons. Okay, with 30 degrees angle. But at the same time, you have to handle 3 moments there. 30 Newton meters, that's the first moment. The second moment will comes from moving the force 20 newtons from D to C, moving the force, and the third moment will come from moving the force from B to C like that. So in total, you have 2 forces and 3 moments. Okay, then those 3 moments you can just sum it up. So you have the total moment, right? And after that, okay, after that, because you have the total moment, then you have and beside that you have to sum the force, the 2 forces, 20 newtons and 10 newtons. You have but you have to do a factor summation there. You get the force there. You get 1 force and 1 total force and 1 total moment. Okay, by doing so, then you can replace that 1 force and one total force and 1 total moment with 1 force in this y-axis. That's simple actually. That's the way to do it. Who are asking me about this question? Who was asking me about this question just now?
Me, sir. I think 100% I got it wrong, sir.
100%. But do you understand about how to do it? Based on my explanation just now.
Yes, sir. I thought there will be only 2 moments, sir. Like the moment we got from moving to C, and also the B.
Moving to C, yeah. So from moving this force here, you will get a moment. Moving this force here, you will get a moment. And from the beginning, you have 30 kilonewton to 30 Newton meters. So like it or not, you have 3 moments there, right?
Yes, sir. But I summed it up, all the forces, and then yeah, it's wrong, sir.
Nah, it's okay. Yeah, it's okay. It's okay. At least now you know how to do it. Okay, and you have to try harder in the second exam. Okay. Nia Aulia, do you want to ask something?
I want to ask something, Pak.
Okay, Rizky, yes.
For the number 2.
Number 2 now. Okay, let's go to number 2. What is the question here?
The question stated that draw free body diagram of beam ABCD, right?
ABCD, yes, correct.
Should we also include the E or what? Because when I'm calculating the B, I didn't put the E to the calculation. I only put the tension in D. So there's no E.
There's no E. So basically, what you're supposed to do when you have something like this, right? Try to always solve for the Pulley system, Rizky. Yeah, I told you already over and over. Right? Correct or not, Rizky? So try to solve Pulley systems and replace all the forces which is happening at the Pulley system to the point. So for example, at Pulley C here, we have one tension here, another tension here. So by drawing the free body diagram of the pulley, then you can replace the pulley with forces which is happening at point C, right?
Right.
And at point D, the same. You have a force here because of tension, you have a force here because of tension, and you have force here as well because of tension. And you have a reaction force at D as well.
Yes.
Then using free body diagram of this particular pulley, you can replace the pulley with the force at point D, with the reaction force at point D. That's all. That's all. Then what you're supposed to draw in the free body diagram is just the resultant force from the previous pulley calculation. Okay.
So like even the tension caused by the E, Pak. So if I don't draw the E, the vertical force in D must be 0. Is it right? And never mind.
If you don't draw the E.
No. I mean, there's only how suppose I describe it. First of all, I cut the system, so I get the tension from the E.
Yes, correct. So there are two tension, right?
Yes. After
here,
that,
there is tension going down. There is tension going down. Each of those mg, right?
Yeah, must be divided equal because there's two rope, right?
Yes, correct. This one is mg. Sorry, not mg. Yeah, mg per 2. Here is mg per 2. This one is mg per 2. This one is mg per 2.
Yes.
mg per 2, mg per 2. Yep.
Then in the A stated that I only need to draw free body diagram of ABCD. So is it right if I only draw the stick, but I show there's an extra force by the tension just only by arrow, not drawing the E also?
It's okay.
Oh, okay.
Yeah. So basically, it's up to you, right? It's up to you to draw which free body diagram. You can include the pulley, or you don't want to include the pulley. If you don't want to include the pulley, only A, B, C, D, like what I normally teach you, means that you have to solve for the pulley first, for the external force, for the reaction force because of the pulleys, right?
Yes.
So basically, how to draw it? Okay, let me copy this to the slides. But overall, what do you think about this risky? Can you still handle the whole problem, or you can't?
I think if I have more time, I can I can handle the problem, but yeah, I run out of time.
It was lack of time. So for you, it was lack of time then.
Yeah, because I think because the exam start at night, my brain doesn't work fully. Its capacity.
You sure about it?
Yeah,
because normally students works better at night.
I think because at 3 to 3 to 6.
It's just that we had a whole day before.
I have
right,
practicum and only have like 30 minutes to prepare the exam, so I don't have enough rest.
I see.
Yes, sir. I don't agree on night time, sir.
But statics will always happen at night.
Yeah, I mean, if it's night, but in free day like Saturday, it's better because in Friday it's so many things to do.
Okay.
But
Yeah,
at night at Saturday we will just finish with collaborative learning.
Or
Yeah, of
Wednesdays,
course.
actually, best is Wednesday. You don't have any more practicum on that day.
Oh, so Wednesday is better for you. Okay then. So next time, if
no, Zik, but the other class have class.
Oh, I'm not sure about that though.
Only international class free on Wednesday.
I think
Yeah, but,
for each number we have a full hour, it will be better, sir. Unfortunately, I'll just
full hour,
get stuck in
it won't
the
be
spring
possible.
part.
That
Yeah.
it's too much. It's too much if you are asking for full hours for each problem. To be honest with you, I can handle this particular problem in 10 minutes. Okay, so basically, this is the kind of problem that you can do it fast. Okay, let me share this one.
I stuck in the last section.
Last section. What do you mean by last section?
When I try to find the FB, it's a bit hard for me.
FB. Why is that?
Because we need to know the force of the spring to find the K.
Because you need to find the force
of the spring
determine
to find
reaction force.
To determine the K, because we asked.
Determine the stiffness of the spring in. Okay, use grid. Okay. So
what I do in this question is for the AY, I use moment in B, and I get the AY but the other I don't know. For the AX actually I don't know if it's wrong or not, but I cut it in the middle of B and C.
Okay.
But for the PF, I don't find a way to find it.
But actually, in the problem at equilibrium condition, spring FB is stretched 10 millimeters. There is an information like that in the problem. Is key.
Yes.
So basically, if you know the value of the force FB, if you know the value of this FBF, right? If you know the value of the force FBF, okay, the stiffness, right, K, the stiffness
minus K times the
minus K, what?
Minus K times the what?
So it's supposed to be like this, right?
K, yeah.
K multiplied by delta X is supposed to be the
I mean
force, right? So if you want to find the K, so just FBF divided by delta X, right? That's all.
Yes. I stated that in my answer sheet, but I don't find the FB. FBF.
I have a question. What is the most effective way to approach this question?
Like what I normally told you guys. So basically what you're supposed to do is to draw the free body diagram, right? You can draw the free body diagram like this. Okay. The unknown there is AX, AY, and FFP, right? And at point C, after you draw the free body diagram of the Pulley C, the free body diagram will be like this, right? Okay, mg per 2, mg per 2. Then we have this.
Yes.
Okay, we have, wait. Okay, something like this. So we have C1, Cx like that. Okay, you can find Cy and Cx. Then you put it there. Okay, and beside that, at point D, as well, the pulley will be like this. It will be mg per 2. It will be another mg per 2. mg per 2, right? And you have this dy dx. Find dy dx. Find cx cy. Then put it here. So now cx cy is the known value, dx dy is known value like that. And you can put it in the your main free body diagram. Sorry. Okay. So later it will be like this. Cx, cy. Then dx, dy. This one is known. We have three unknowns there. Ay, ax, ffb. Using sigma fx equal to 0 and sigma fy equal to 0 and sigma moment equal to 0, you will be able to find everything. Okay, you will be able to find ax, ay, and ffb. So the first problem is to find ax and ay. Then solve for this three equation to find for those three forces. After you find ffp, then use this k equal to fp divided by delta x. Delta x here is 10. Okay, I'm not sure there is 10 centimeters or 10. Oh, 10 millimeters. 10 millimeters. So 10 to the power of minus 10 per 1,000 meters, right? So 0.001 meters. Then you will be able to get K. That's it. Okay, Rizky, you get it, Rizky?
Yes, Pak.
Okay, I believe it's not supposed to be that hard, right? Okay, stop share, and then I will share again this particular problem. Okay, that's the problem. For number 3, do you have any problem with number 3?
I only find it half away, but
Why? Why, Rizky?
yeah, I think it's the same reason that
Not enough time.
Yeah, not enough time to think.
I think in that case, okay, you guys need to study harder. Not study harder, but practice more. Practice more for the next exam, because practice makes perfect. That's the thing that I told you guys over and over again. Okay, practice makes perfect. So for this one, okay, this is the problem that is asked for number 3. Figure 3 shows a truss structure that is loaded with F1, F2, F3, F1, F2, and W. F1, F2, and W. 100 Newton, 200 Newton, and 150 Newton. Okay. Then you are asked to find out the zero force member. Okay. You are asked to find out the zero force member by inspection. Can any of you find the zero force member there?
EF and AE, sir.
EF.
EF. Bravo, Foxtrot,
Bravo,
and Alpha
Foxtrot.
Echo.
And
EF. Why PF?
AD
Why
and,
AD
sorry?
and DE, I think. sir.
AD and DE.
AD and DE. Yes, it's correct. AD and DE. That's the first type of zero force member. AD and DE. When you have a two collinear member met each other, okay, only those two there in one joint, then those two will become zero force member. This and this are zero force member. This and this are zero force member. So DE and AD are zero force member. That's all. Yep, that's all. Nothing else there that is supposed to be zero force member. So actually you can just exclude this and this you can exclude it. Then calculate the force on the rod EF. Okay, force on the rod EF, BC, and HG. Where is H? Oh, HG, this one. So PF, sorry, PEF, EF, BC, EF and BC. Okay. Okay, so basically what you're supposed to do here is by all these forces, right, is to try to solve for the forces which is happening here. Okay, forces which is happening here and which is happening here. Okay, but the number of equation will not be enough to solve for AX, AY, HX, HY. Correct, right? Because there are supposed to be 4 unknowns, but we only have 3 equations: sigma fx, sigma fy, and sigma moment. In that case, you have to remember that GH here is to force member. Okay, GH here is to force member. So you can replace GH here with external force. Okay, with FGH. So you can replace at point G. You can replace GH with FGH like that. So the unknowns will be FGH, AX, AY. 3 unknowns, 3 equations, and you can solve for that. You can solve for GH. Okay, you can solve for GH. You can solve for AX, A1. Okay. Okay, then after that, after you solve for those, you can do the cutting here to find for EF and BC. That's it. Okay, do you get it, guys? Hello?
Yes, sir.
So basically, that's the way to do it. Any of you here have a confidence on doing all the problem given to you guys for this particular exam?
I have a bit in question 1, sir, but I think it's all about to disappear.
On question 1, you can solve it. Then that's it. Azar.
I just feel like I could, but I'm probably wrong.
Nah, it's okay.
Sir,
I think if it's a homework, I will do it nicely, but
Next homework. So the previous homework, you haven't done it nicely then. What do you mean by that, Rizky?
no, I mean if this is homework, so I have
Mhm.
so many time,
Time,
I can do
okay.
it nicely, but
Okay. But because the time constraint is quite short, right? Okay. For question number 1, we have 35 minutes. Okay. Then question number 2, you have how many minutes? 35 minutes as well. Question number 3, another 35 minutes. I think it's supposed to be enough. Yeah. Want to ask questions just now?
Me, sir. How will you grade our answer?
It won't be me. So basically, the good thing is about statics, right? The grading for all the classes will be the same. So basically, all of your papers, right? All of your papers will be submitted together in one folders like that, and one particular lecture will have the responsibility to grade one particular problem. So, for example, maybe number 1 will be graded by Bu Anissa. Number 3 most likely will be graded by Pak Ferry. Number 2 most likely will be graded by Andi Puspoya. Okay, and after that, for the next exam, the same thing we will do the same thing. Maybe at that particular exam, I will grade one of the problems. But for all of the students from all of the classes, then at the end of the semesters, all those grades will be joined together, and the grading will be we will use the normal distribution grading. Okay, normally we will use normal distribution grading, but for the whole batch. So not for each class, but for the whole classes. That's the way we do it. Any question?
I want to ask, sir.
Mhm.
So for example, for number 3, if we draw the correct free body diagram, we're gonna like get points, right, sir? Even though our answer for B and C are wrong, something like that.
Yes, of course, you will get it.
Okay.
That's the good thing of dividing it like A, B, C, D like that. Okay.
But if you're already wrong in A, you are totally wrong in B and C. What?
But sometimes the lecturer will take a look at it. Sometimes not as well. It's up to the lecturer. Okay, who has the responsibility of grading that particular problem. Okay, so the step by steps will be graded there, so you don't have to worry about it. Okay, basically, and for those who think that you fail for this particular exam, use that to motivate yourself. Okay, please use that to motivate yourself, because not necessarily by just failing one particular exam you will fail the whole subjects. No. So this is just like a reminder for you guys. You need to study harder. That's one thing. The second one, you need to practice more, because practice makes perfect. And you now know that the time limit in the exam is quite short. So next time when you practice, try to use that time limit for yourself. Okay, so you get used to the exam. Okay, you get it, guys. Yeah, Matthew.
So
Yeah, I'm
the
wondering
grading-
about you, Matthew. Can you get can you answer the whole or all those 3 questions?
Matthew, very easy, smart.
Semester, sir.
Oh my God, here we go again.
He told me
They
after
always
test,
bully me, sir.
he
I
told me
feel
after test,
intimidated.
oh, I think I'll get perfect. He told me after test.
Okay. Nah, it's okay.
Sir,
Yeah,
I'd
so-
like to ask.
Sir, and then he called us stupid, sir.
That's a lie. Oh.
Right, exactly, sir. 100%.
Don't bully Matthew, okay? Please don't bully Matthew. Try to ask Matthew to study with you. Don't bully him, okay? Okay, I understand you.
My tutor is Zeke and Fauzan actually, sir.
Sir, no. When we asked him to study together, he said he don't want.
Yeah. Okay, I don't want to. I don't want to hear this kind of fight in my class. Okay. So, what question that you want to ask Matthew? And no one bully Matthew in front of me. Okay. Not in behind me as well. Okay. So don't bully your friend. Okay. Please do. Please be nice to your friend. Okay, Matthew. Yes.
So, sir, the grading system will be normally distributed for the whole FTMD batch. Yeah?
Yes, correct. It's
Oh.
not just for one class only. That's the. It can be good news. It can be bad news as well.
Bad news, sir. If somebody got perfect in the test, then it's over.
Pak,
It's okay. It's
the
not.
one I want to ask is how the grading system of the final in the end of the semester will be like
All 20%. So please do well in your homework. Please do well in your collaborative learning.
I mean,
And
like
please do well to those 3 exams that you will face or you have faced. Okay. So you have faced the first exam and you will face another 2 exams. Okay. And each exam will give you 20% grade, 20% grade, only 20%, or actually it's not only 20% is quite a lot.
so.
And, yeah.
Where's the other 60% came from?
What do you mean?
Like
20% from the exam, first exam, 20% from the second exam, second midterm exam, 20% from the final exam. So those are 60%, right? From
so there are three exam for status.
Yeah, 3 exam. And then we have collaborative learning is another 20%, and your homework and quiz will be another 20%. That's why it's better for you to do well in your homework, 20%, collaborative learning, 20%. Because normally those two will be the things that will save you guys.
Yeah, I love doing collaborative learning, but
okay, please do well there.
But the one I want to ask is like in mathematics to get an A, you need to score 80. In physics, 75. What about status?
Distribution key.
Yeah, but normally even though we use distribution, but almost every year the grading will be more or less the same, and yeah, around 80 to 85 like that. Depends. Yeah, depends on the distribution for A. Yes.
Wow, that's quite high.
No, it's not that high. No, because you will do well in your homework and in your collaborative learning.
I see.
It will push you up. That's why it's better for you to do very well in both. Okay, homework and collaborative learning, because it will help you. And besides that, if you think that you fail this particular exam, then try to study harder in the next exam and in the final exam as well. And not just close to the exam, but starting from now. Okay. Statistics is not a very hard subject, but sometimes the problem given will be challenging. But even though it's challenging problem, but still it's solvable. So you don't have to worry about it. Okay. Why the current problem, if you see here, is quite a new problem, and you will not be able to find it in the book or in the internet, because we create this problem by ourselves. Okay, I'm telling you, we create this problem by ourselves. Why? Because previously we used the problem that we have in the book, in the online exam, and You know what happened last semester, right? In the mechanics of materials, I believe you heard the rumors, right? It's around 50 to 60 students got caught cheating. I'm telling you guys, 50 to 60 students got caught cheating, and those students, they will face they will get they got a straight E. So it means that they failed the subjects. That's one. The second thing is for those. The second thing is most of them will have a note in their surat pengantar ijazah, ya, SPI, ya. Okay. I'm not sure what's the name in English because we don't have that things in the other university.
How do they got caught?
The answer. Okay. You are not cheating, right? See?
Of course not, sir. How could I?
Okay, good. So because from their answer, we can see from students' answer whether they are cheating or not. Okay, lecturer is the lecturer that teach you guys is a experienced lecturer, so we know whether students are cheating or not from their answer. Okay, so we know the techniques behind that as well, based on the information that we got from the students who were cheating and they admit that they are cheating. Okay, they told us that they use a website to help them to finish to find the solution online. That's one thing. The second one, some smart students post the answer. So some smart students can finish the answer fast, and they posted it in the small line group or WhatsApp group like that. Okay, and those who belongs to the groups can copy that. That's the second one. Okay, and we call all. So I don't know, I forgot, 60 or 70 students from 350 students. Sorry, 350. It's not 350. Minus 80, maybe 280. So 60 or 70 students from 280 students. Okay, got caught cheating.
Is it from the last semester or?
Yes, last semester. So your seniors, 1 year seniors.
So when was still in TPB1?
No. You are currently in TPB, right? So your seniors.
Like before.
So you are 2020 batch, right? So 2019 batch.
Oh, I see.
Yeah. So last semester, you happened last semester. Okay, so please be very careful. Try to do it by yourself. Whatever grade that you get, as long as it's from your own power, from your own ability, be satisfied with that. Because it's your own grade. Okay.
Pak, the person who cheat get an E, straight E.
Yes, all.
So even who work jujur have help by them because they
Oh, so you mean the one giving
Because
the help as well?
Yeah.
Yes.
Yeah.
The same. The one who give help and the one who get help both got E.
Because they are complicit, right, sir?
Yep.
Maksud saya gini, Pak.
Cheating is cheating. Yep.
Kita kan meskipun jelek tapi nggak cheating, pas normal distribution kebantu sama mereka, Pak.
No. The normal distribution we created before we put the E there.
Oh. Okay.
So yeah. Actually, it's not. You won't get help from that as well. Okay. But that's a quite bad thing. So please don't do that because there are a lot of students who got caught doing that, and some of those after they got caught, they didn't admit that. That's why they need to. We proceeded them to some kind of a, what you call it, prosecution room or something like that. And in that particular online room, right, we give all the evidence, and they can't say anything. They cannot say anything. That's all. Okay. And the worst thing is when you got cheating, it will be there in your SPI, surat pengantar ijazah. Surat pengantar atau surat apa ya? Yeah. So later, what you will get, right, when you graduate, there will be your certificate, there will be a transcript, and there will be this one, another document, SPI. SPI or what? I forgot the name. But it will be there when you got caught cheating. So please don't ever try to do that. Okay? Why all of you be very quiet? It doesn't. Don't say that you were cheating, right? You are not cheating, right, Matthew?
Of course, we couldn't, sir.
Sir, how could
Yeah, we couldn't, sir.
How can
We couldn't,
How
sir.
could student
Yes, sir.
with IP 4 cheat, Pak?
Yeah, how could, sir?
Yes, sir.
Don't bully Matthew, okay? Anyone
Yeah, I
who bully
feel
Matthew,
attacked.
I will bully them.
Anyway, sir, it's open cam. It's very difficult to do that stuff.
Hey, the previous one, it was open cam, and it happened as well. See, okay, you know, sometimes when someone wants to do something bad, whatever the situation is, they can still do it. Right? That's why there is a police and there is a bad guy. Okay, and normally the bad guy will try to. Yeah, I think what?
I think
You think what?
it's not worth it, sir, because we know that the effort is still graded, so we'd rather do the effort.
Yeah, and anyway, for the because that thing happened, now all the subjects in our faculty, right? All the lecturer will try to create a new problem for you guys in each exam. So most likely it will be very hard for you to do those kind of online cheating anymore. Using the help of the web or something like that, yes, at least that one we scrap it. But among you, you can still do that. But please don't do that. Okay? Because whatever you do, we will catch you. That's the thing. Okay? So please don't do those things because yeah, it's not for me, right? If I do well because of cheating, right? I'm not that proud with that. Okay, that's the first thing. The second one, whatever you do, you will get caught. So why you need to do cheating then? That's the thing. Okay. Okay, I think for the exam, it's supposed to be okay, right? Anyone else want to ask question about the exam?
But
after
in the exam 2, exam 3, we it's not about like trust equilibrium again, right? But we still use the theory.
Yes, correct. Yes. For the second exam, like the second midterm exam, trust will not be there, equilibrium will not be there. But in the final exam, it will cover the whole things that we gave it to you guys. And you have to remember that equilibrium is actually the basic for the whole statics. Okay.
So
yes,
it's regarding the grades. So do you know how many % of the whole batch get an A score last year?
A.
Yeah, like maybe 10% or 6% or 40%, something like that.
Normally it's around 10% only. and it's way better than my time. Okay, at when it was me at your age, right? When I was at your age, it was less than 5%. So in each class, normally the one who got A is just 1 to 5 students like that. So yours is supposed to be way easier than my time. Okay, 10%. So it's quite okay, 10%. Okay, anyone else want to ask question?
So can we do number one?
Answer about the number
sorry, Matthew.
of exams.
Can we do
Yeah.
number one?
Number one?
Exam. Yeah.
Just now I did it, right?
Yeah, but the numbers.
The numbers.
I like to ask. So the moment we just can we just relocate the moment to point A without any changes?
Yes, of course you can.
Oh, jadi boleh langsung aja dipindahin habis itu
Yeah.
calculate
Because it's a moment.
total moment.
Because it's one. It's a moment. Okay. It's when it's stated there is 30 Newton meters. It means that 30 Newton meters anywhere in the structure.
Oh, that's one thing I got right.
Tapi it's not in the form of force.
The 30 Newton meter tuh in all places ya, Pak?
So it's conserved throughout the whole body, right, sir? The moment.
Yeah, the one that make me confused is
because it's like this, okay? Where you can put 30 Newton meters like this, okay? Like this, right? If in reality it's supposed to be like a couple like that. So you can draw it like this only if in reality it's supposed to be like a couple. So basically, this 30 Newton meters, it will be there in the whole structure. Okay, 30 Newton meters will be there in whole structure. The same as couple. The amount of moment that you will have in all the points will be the same. Okay, but if it's force, then the amount of the moment which will be faced which will be suffered by point C or point B, it will be different if it's due to force. But if it's due to like this, yes, it will be the same. Okay.
Yes, sir. Is it possible intersectionnya out of the body?
Yeah, it's possible as well.
Oh,
As long as it's in the same line of action, right?
Yeah, but the problem here is what you have to find is the intersection between the resultant force with y-axis. That's the question. Okay.
okay, sir. We can move on. Thank you.
Seems like you got it right for all the questions, right, Matthew?
Oh, sir, it's Matthew. Matthew who?
Who said that just now? Later I will bully you. Who? Sick, right?
Vic is bullied when he hit in Facebook. So now
sir.
online he bully Matthew.
I didn't say anything just now. I was looking at textbook.
I can.
It's okay, sir. It's his way of saying I love you to me.
I know your voice sick, so I know it's you. Okay then. Anyway, that's the exam. So please try harder for the second exam. Okay. For today, I think I will continue with because we still have time, right? We still have around 30 to 40 minutes. So we can still do some more practice for the frame, because until next week, okay, until next week, we will still concentrate on, we will still concentrate on the frame and machine. Okay. Okay, now I think I will try to test you guys. What do you think about this? Is it a frame problem or a trust problem?
I think it's a frame problem, sir, because the force is also applied at C so far as I see it.
Because this one, PCD is actually one member, okay, and it's a rigid member, okay, it's a rigid member. Two force member of the loaded truss are the same length. Member PCD is rigid beam, okay. Determine the forces in the member PG and CG in terms of the load L. Okay, PCD is a rigid beam. Okay, PCD is a rigid beam. So the meaning of rigid beam means that it cannot be moved and there will be no deformation there. Okay, and you can make it like the same as the so how say that? Okay. So basically, rigid beam is something that you cannot deform like that. So basically, for example, if I have a beam like this, and it's a deformable beam, okay. If I fix at this particular end and I put a load at the other end, okay, it will deform. Okay, it will deform. When we talk about rigid beams, so when we do it the same way, like this, and we put a load like this, then it will not deform at all. So that's why we can call it as rigid beam. Okay, and in this case, a PCD is a rigid member, a rigid beam. So it's one whole beam, very long, from B to D. Okay, and it's rigid. Okay. Yes, Asaf.
Sorry, sir.
Okay, so it's it's rigid. And now the one in question is determine the member forces in member PG and CG. PG and CG here. Okay, in terms of load L. Okay, the rest are two force member. AB, BG, CG, CF, and DE are two force member. So how can we solve for this particular system then? Any idea?
Perhaps with joint methods, sir.
Joint method? Maybe, yes, but before doing joint method, what we supposed to do?
Find
have
all
to
the
solve.
external force, Pak.
Yes, correct. We have to solve for the whole free
AX,
body diagram.
AY, and EY.
Yeah. So basically, it's still a truss member. It's still a truss. It's still a truss system, but BCD you cannot treat it as a truss. So you have to treat it as a you have to treat it as the another member like that. Okay. So it's like this. Then we have AX, AY. And we have EX as well. Okay. and we have force FL here using sigma Fx equal to 0, sigma Fy equal to 0, and sigma moment equal to 0, we will be able to get for those three, Ax, Ay, and Ex, or Ex, by Ex, Ey, sorry.
EY, because it's roller.
Yep, Ey. So we got to it. After we got all of those, then we can try to solve it using a join method. Okay, we can start from join A to solve for AB and AG. Then after that, we can solve for join E to solve for DE and FE. Then we can solve for join this, join F to solve for this and this. That's it. Then we can go for join E to solve for this and this. Join method, yes, we can solve it. Okay, so basically, this one is still trust problem, but you cannot treat BCD as a trust because BCD is known there as a rigid beam. Okay. Then for this one, what do you think? Is it trust or not? Although my question is quite stupid, right? It's quite it's a very knowledgeable. Who here I will ask. Aaron David.
Yes, sir.
What do you think? Is it a trust?
Sorry, sir.
Is this problem is a trust problem?
Me think about it for a bit.
Trust, you know trust, right?
Yes, sir.
All of the member there, two force member or not? Aaron.
I think it's something like the wheel problem on the homework, sir.
Wheel problem?
The landing gear
Oh,
problem
yes,
in the
it's
homework.
similar, sir.
Yeah, so it's actually a machine. This one is actually it's not a truss, it's a machine. Okay, it's we can consider this
because
as
it's
frame or
movable.
machine. Sorry?
Because it's movable, right, sir? So it's a machine.
If you want to define, if you want to differentiate between what is truss and machine, we have to go back to the earlier definition. Okay, frame are structures which are designed to support applied loads and fix. Normally is fixed in position, but machine normally is contains moving parts and transmit input force, okay, or couples to output force or couple, and we consider this as the second one, machine. Okay, this one is a machine, but you don't have to worry about that. About differentiating between machine and frame. Why? Because both actually have the same treatment. So you can treat both the same way. Okay, either machine or truss. Machine or frame. So basically, as long as not all the members are two force member, we can consider that as a frame or machine. Okay, but this one is a machine. Okay. Haji Rosadi. Hello, Haji. Where are you, Haji? Don't say that you sleep again, Haji. And Chirosadi?
Lagi naik haji, sir.
Why you keep bullying each other? Darian Patrick, then, in that case.
Yes, sir.
Okay, how can we solve for this, Darian? How should I address you, Darian? Darian or Patrick?
Just Darian, sir.
Darian, okay.
I believe we should draw the free body diagram first.
But before that, before you draw the free body diagram, remember the previous flow chart that I gave you guys, right? Okay, the first thing that you're supposed to do in order to solve for a frame or machine, okay, because we have to keep practicing, right? The first thing that you're supposed to do to solve for frame and machine is to determine which one is the two force member. Can you find out which member is two force member, Darian?
I believe AB is 2 force.
AB, correct. What else?
Then,
Here's another one.
CD.
CD, correct. CD. Only those two. Those two are the force member. Okay, so after you know which one is two force member, then you can replace those members with external force. Okay, Darian, why we can replace that with external force? Because when it's two force member, the forces which is happening at the member, at the particular member, will be either tension or compression. But you have to remember that the line of action, like it or not, will follow that particular member. Okay, for AB will be like that, for CD will be like that, right?
Yes.
Correct or not, Darian? So that's why
Yes.
we can replace that with two force, with external force. Okay, with the same line of action as the line of action of the member. Do you get it, Darian?
Yes, sir.
Okay. And now, please let me know, Darian, what force that we're supposed to find here.
So, like the question in general, or the forces?
Yes, of course.
Oh, okay, so
The one that is in question, the one that we
hydraulic-
have to find.
the hydraulic cylinder of A, B, and CD. So the two external forces, basically.
Yes, correct.
And
So
the
the
resultant,
two, yeah, and
yes,
is that it?
and the resultants at pin E and F.
Okay. So basically, the forces happening at here and here we have to find, and the forces happening at here, okay, we have to find, and F as well we have to find, right?
Yes.
So now, what do you think? Which one that we can solve first?
I think we can solve for E first, perhaps.
E, yeah,
Yes.
because there the mass 500 kilograms is known, right?
Yes.
And the center of gravity is here at point G.
Yes.
Correct, right? So we know about it. Then, in that case, we can solve for this particular small system first. Correct, right?
Yes.
And can you help me to finish this particular free body diagram? So if I want to draw it, then I draw it like this, right? This is the bucket. And the mass as well. So this is it. This is the free body diagram. This is the point where this is the G, the center of gravity. And this is point A. And this is point E. Can you help me to finish this particular free body diagram?
So it will be 5,000 newtons downwards
At
from G.
G,
At
right?
G, yes. And
So
then
this
the
5,000 Newton. What else?
The distance between G and E is 0.1 meters.
G and E 0.1. Okay. About the dimension, right? And
Oh yeah, dimension.
distance
Yeah.
between E and A is 0.3 meters, right? Yeah, you have to complete that, but I will not draw it here because
okay.
the one that I want to draw it here, you have to complete that. Okay, when in your free body diagram drawings, you have to complete that. But at point A and point E, that's the things that I want to know: the direction of the forces at point E and the direction of the forces at point A.
Okay. So E will be to the right.
Point E.
Yes.
Point E is a pin, or so. Take a look at this.
Oh,
is this a two force member or not?
Sorry. No, it's not.
So in that case, it's a pin then.
Yes.
If it's a pin, then it's supposed to be what?
EX.
Oh, yes.
Y.
You cannot just do it that way. Okay, this one is supposed to be what?
EX.
EX and EY, right?
Yes.
Okay. And at point A, AB is two force member or not?
It's two force member.
Then at point A,
so only one force.
Yep. I
believe it should go to the
it's
left.
up to you. You can do it to the left or to the right later. If it's negative, then it's the opposite is supposed to be the opposite direction. So you want to do it to the left or right?
To the left, so it will cancel
the left.
the EX.
Okay, to the left and FAB. If it's to the left, what's the meaning there? At AB will it AB is under your assumption is AB under compression or tension here?
Tension
to the left. Tension means the AB is pulling the bucket, but now AB is pushing the bucket. It's compression, right?
Oh, okay. I got the definition wrong, sir. I flipped the definition.
So tension go out from the point.
Yes, tension is going out from the point.
Compression going in.
Okay. Thank you.
So if you, what Rizky said is correct. If you take a look at the joint, if you take a look at the joint, the compression thrust, if the compression member, compression of the two force member which is under compression, the force at the joint, it will be going inside of the joint. But if it's tension, then it will be going outside of that joint. Okay.
Okay.
So now, how many unknowns here?
3.
3 unknowns. 3 unknowns, 3 equation, we can solve it, right?
Yes.
Okay. Can you solve it for me?
So we have
try to solve sigma moment at E first.
Okay.
Sigma moment at E equal to 0. What we have there?
Sigma moment at E equals to 0. We have 5,000 newtons. Yeah. 5,000 newtons multiplied by 0.1 meters.
So counterclockwise is positive then in that case. Then what else?
Plus FAB times 0.3 meters.
0.3.
Yes.
You share 0.3.
It's at point here, right, sir? Yeah, 0.3. Oh, y-axis 0.25.
0.25. Yeah, because it's horizontal, right?
Yes.
Okay, and it's counterclockwise. Yes, it's correct, counterclockwise. So FAB multiplied by 0.25. meters equal to 0. The result will be FAB equal to 500 divided by 0.25 minus, what is the result there?
So negative 2000 newtons.
Sorry. This one is 500. Yes, correct. Negative 2000 newton. So the real FAB is supposed to be going to the right.
Yes.
Okay. Then using sigma fx equal to 0, what you will have there?
EX minus 2000 newtons. So
EX minus FAB
yes,
equal to 0.
0.
So EX is the same as FAB,
FAB.
right?
Yes.
Equal to minus 2000
newtons.
Newton. So EX is supposed to be going to the left, right?
Yes.
Then using sigma Fy equal to 0, what you will have there?
Weight.
We have
weight.
only two.
Yeah, weight
Y
plus
and yeah.
weight minus EY.
Yeah, so 5,000 Newton minus EY equal to 0. So EY equal to
5,000.
5,000 Newton. So the direction is correct for EY. So you got EY, you got FAB, and you got EX. Where is my EX? Oh, this one. EX as well. So we have all that. Then we have, so in this case, we have finished this, if AB, EX, EY. Now we're left with CD and FX, FY.
Yes.
So which free body diagram that we're supposed to draw that?
The CFD.
CFD, YD.
Eh?
Which free body diagram that we're supposed to draw?
Oh, BCF maybe, sir? If it's not CFD?
CF.
Because
this
CD
one.
is external force, so it will not.
Yeah, CD is external force. So what you're supposed to draw is actually the member ECF, EBCF, that one. So you have to draw the member of EBCF there.
EBCF. Oh. How? Okay.
So you have to draw it like this. No, this one is supposed to be slightly longer. Yeah, roughly like that. Okay. Remember that at E we have EX, EY, right?
Yes.
EX there is going to the left, 2000 Newton. EY is going up 5,000 Newton, right?
Yes.
Okay, because it's action and reaction, so EX and EY here is supposed to be the opposite of that direction. So EX here is supposed to be 2000 Newton to the right. And EY there is supposed to be going down 5,000 Newton. Do you get it?
Yes.
Because it's action and reaction.
Yep.
Okay. Then at point B, is there any force at point B there?
Yes, from the FAB.
FAB, and FAB there is supposed to be tension, right?
Yes.
Because it's minus, right? Just now you assume it as compression, and it's minus, so it's supposed to be tension, 2000 Newton. So it's supposed to be 2000 Newton going to the left or to the right?
Since it's tension going to the left.
Left, right. So that's the way to determine the direction of the two force member, Darian.
Yes.
Okay, just now you assume it as compression, but the value is negative. So it means it's supposed to be under tension. Then at point B is supposed to be under tension as well. Right? So
Yes.
this one is 2000 Newton. What other force that we have there?
External force of FCD.
FCD. You want to assume it as tension or compression?
Compression.
Compression. Okay, compression. So if it's compression, it's supposed to be going up or going down?
Up.
Up. Okay. So it's supposed to be slightly like this. FCD. What else at F then?
At F, since it's a pin, so Fx and Fy.
Right. So I just assume it like this. Y. Fx. Now, try to mention, try to take a look at that. How many unknowns do we have?
We have 3 unknowns.
What are those?
FCD, Fy, and Fx.
CD, Fx, Fy. How many equations that we have?
3.
Okay. Sigma Fx 2 equal to 0. Sigma Fy 2 equal to 0. And sigma moment 2 equal to 0. Why I put 2 there? Because that's our second free body diagram. This is our second free body diagram, and this is our first free body diagram. Okay, Tadian?
Yes,
Can we
sir.
solve for those 3?
Yes.
Yes, we can. 2 equations, 3 unknowns, but I will not try to solve it here because it will take too long to answer. Okay, so it's there is a problem with the angle, everything. You have to try to find the angle between CD and CF, right? This particular angle, okay. Okay, so this particular angle you have to find it. So that's the thing that you're supposed to do. Try to find the whole dimension. Or you have to find it or not. Yeah, wait a minute. Just you have to, because actually you don't have to find the angle here, but you have to find the angle of FCD here. The angle here you have to find. How to find it? You have 0.4 meters there, and you have the height there, 1.25 plus 0.6 meters there. So you will be able to get the angle there. Okay, it's supposed to be clear enough. Huh? Darian?
Yes. Yes, sir.
Okay, good. Thank you very much for helping me, Darian.
You're welcome.
Okay, now, because we need to practice more, okay, Darian, please try to point out, please try to pick your female friend here. The one that you want to, the one that you want to bully the most.
I guess I'll just choose Florencia Irena.
Florencia Irena. Florencia Irena?
Yes, sir.
Okay, because Darian want to bully you, then you are next then. Try to help me to solve this then, Florencia. How are I supposed to address you, Florencia? Florencia or Irene?
I think we should add the external force at the A.
Answer me first. How should I address you? Florencia or Irena?
Oh, sorry. Oh, Rena.
Irena. Okay. Rena.
Yeah.
Oh, Rena. Okay, Rena. So, so for Rena, for the others as well, this is another types of machine. This one we consider this as a machine as well, because we transmit, we transfer the force here to the force here. Okay, so basically it's a by using this, the force at this particular things will be much more than the force given at this particular ends. Okay, now how can we solve for this particular problem, Mirena? The one in question is the force which is given to the round rod there at this particular things. Okay, but how can we solve for that? Irena, Rena.
Adding the external force at point A.
Adding the external force at point A. Which free body diagram do you want to draw first?
AX and AY.
AX and Y. What do you mean? So we don't have to modify for the whole things. We can just solve it directly. Maybe.
Oh yeah. Maybe we took the upper part.
Yes, correct. Actually, it's up to you. Up to you guys. Up to you, Rena. You want to take this one or the other one?
Yeah.
Number one or number two? Which one do you want to take?
The second one.
Second one. Okay, then it's okay. Actually, both will give you exactly the same results. Okay, so we draw the second one there. Okay. After drawing like this, what forces that we have here? Rena.
The 80 Newton force.
80 Newton. Yeah. 80 Newton here. Right? What else?
Yeah, correct. For the A, should we add the AX at Y?
Yes, correct. That one as well, AX, AY. What else?
In the ball, what's that?
This one here.
Maybe the 80 Newton reaction force in that part.
Yes. Sorry, I don't understand.
80 Newton force. Reaction on the that ball part.
Why? No, that one is unknown. No. So
okay.
you're supposed to put another force here. Okay, because it's supposed to be at the rod will be under compression. Right? So it will be like this. So this is the F here. The one in question is that the F. This particular F. The force that's supposed to be happening at the rod. That's the free body diagram, Rena. Okay, do you get it?
Yes.
Or else, for you guys who don't want to draw the second part of the flyers, right? Actually, you can draw for the first part as well, and it will give exactly the same results. It will give exactly the same results. So you can draw it like this. You can draw it like this. Okay. Okay, you can draw it like this as well. Okay, and here, then the force will be like this, 80 newtons going up. What else that will be there? Because AX, AY here going right and up. Here it will be going left. AX, AY going down. And here there will be another F as well. So you can use either this particular free body diagram or this particular free body diagram. The result will be exactly the same. Now, Rena, asking me if you are using the second, this one is the first model, and this one is the second one. If you use the second one, okay, like what you said before, how many equations that we have there and how many unknowns that we have there?
Three unknowns for
Three unknowns.
AY, AX,
AY, AX, and F. How many equations there?
sigma moment at A.
Sigma moment at A equal to
sigma
0,
F.
yes, okay. Sigma Fx equal to 0 and sigma Fy equal to 0. Yes. Three equation, three unknowns, it can be solved. Now help me to solve it, Kirana, because it's very easy to solve actually.
Sigma M equals to 0.
Yeah, sigma moment at A equal to 0. What you will get? Yes. What will you get then?
The F times
F times
T5.
35. Yes.
Oh wait. Plus.
Plus, you sure? Okay.
Wait.
You want to use what is the direction, positive direction that you want to use? As usual, clockwise or counterclockwise positive. Okay, in that case, F multiplied by 35 millimeters positive is correct, and then
positive. Then it's minus 80.
80 Newton multiplied by
times 95
millimeters equal to 0, like that, right?
Yeah.
Okay, so F supposed to be
wait, let me
80 multiplied by 95 divided by 35, right?
117.14.
Sorry?
217.14
117.14
Newton going downward.
Going downwards, yes, correct. 217. Okay, let me check. 80 times 95 divided by 35. That's correct. Okay, thank you, Rena. Okay, so this is the answer. So the you can see that the force given at the handle is 80 newtons, but the force which is happening at the round rod is 217.14 Newton, which is much higher than the 80 Newton. So that's the use of pliers. Why the design is like that is actually to increase the force, to increase the biting force to the things that we that is there. Okay. For these two problem example, any question there? Tomorrow we will continue. Tomorrow we will continue another problem example. Okay. Tomorrow we will continue with another with several other problem examples like this. Okay. Like this as well. Like this. Like this. So some of those will become your homework, and some of those will become your the problem examples that we will discuss in the class. Okay. Any other question about this? or today's class is clear enough?
Sir,
Yep. Who's this?
I have another question.
Oh, see. Yep. Yes.
Matthew wants to know when will the score be released.
Matthew or you wants to know?
Matthew, sir. He
Matthew, Pak. Matthew also
see.
tell me in line.
Yeah, he told
Hey,
me.
Rizky, ask Pasatrio to where the score will be.
Why
Instead.
all of you keep bullying Matthew?
Oh,
Why, Matthew?
No, it's
Matthew,
true.
why your friend wants to bully you?
Really, sir, this one really happens. He told me. He messaged me and say, ask Pasatrio, please seek. So okay.
I don't know what to say anymore lah.
Hey, Matthew, tell the truth. Don't lie.
Okay, I'm not so sure about that. Okay, normally, the first exam will be the grade of the first exam will be published before the second exam. Normally we will do it that way. But for the second exam, the second midterm exam, because we will do it quite close to the end of the semesters. Normally, the score will not be published. So the same as the final exam as well. But later you will get your grades, and that's all. Actually. So normally the one that will be published to you guys will be the first exam. But normally you will receive it normally. I'm not sure because everything depends on the lecturer who create that. Before the first exam, before the second exam. Normally it's before the second exam. Okay. But whatever happened with the first exam, whether you think it's successful or whether you think it's unsuccessful, please study hard for the next exam, and please try your best for the homework and the collaborative learning, because the grade there is quite substantial as well, because both each of those will have a 20% grade. Okay, I believe it's clear enough, right? Any other question?
It's pretty clear, sir.
Okay. Okay, in that case, I think that's all for today. Then see you guys tomorrow morning at 7.
Thank you, sir. Have a nice
Yeah.
day.
Yeah. Please wake up early tomorrow. Okay then. See you guys. Bye.
Thank you, Pak.
Thank you, Pak.
Thank you. Bye.
Thank you, Pak.
Thank you, sir.
Thank you, sir.
Okay.